Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects, titled Design and Implementation of a Grid-Tied PV System with Battery Energy Storage for Stable Power Output. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the applications that we have designed in the domain of power systems, especially from the current grid-based systems. So the system that we have designed here is to provide the stability in the BESS, that is battery energy storage systems, where a constant power is to be fed by proposing the hybrid method of the PV systems and the normal battery inputs. So what exactly we have done into this, let's talk about that. Before starting the video, let's talk what we will cover into this video. In this video, initially we will talk about the application areas in which the developed system can be implemented. Along with that, whatever the model we have designed, how to execute it, and what are the software requirements for it. Next to that, we will talk about what exactly we have implemented in the current system and what problems it is resolving. And finally, what are the experimental outcomes and the findings we found from after the simulation. So let's talk about the application areas. So battery energy systems are basically the systems, those are quite similar looking like this, in which at particular locations related to the different areas, such kind of energy storage has been implemented. Now the issue is like when there is a continuous power source, then they are getting stored the energy in them, and when there is a cutoff in the power, these BESS systems are further using the power to run the systems. So these BESS systems are specifically implementing in many of the areas like transportation, commercial use, residential use. As you can see, many of the grids are now working on the basis of like storing the generated power in the BESS and further fed to the utility grids or the home. Other than that, for the transmission and distribution lines, substation and utility grids are there, where the BESS battery energy storage system, such kind of systems can be implemented. It is one of the boom research area for the power sector. So for the solar energy systems, for the electrical vehicles, for grid connected systems, this is one of the effective domain. So now let's talk about that what we have designed and how to execute that code. We will provide you the code folder name code under which the model designed has been placed. In order to run this particular code, you just have the MATLAB software with you. So the MATLAB software should be 2019 or 18. You can use the previous version also, but in that scenario the MATLAB is to be converted to a specific format. So you can use 2016, 17, 18 or 19. So currently I am using 2019. So in order to run the code, you just need to go to the folder where the code has been placed and copy the path of the folder. Then go to the MATLAB and just paste the path and press enter. When you will press enter, you can see all the files are there in the current folder, out of which initially you need to run two of the files. I'm just clearing it, clcs, and this there is no variable initiated. So inverters filter parameters has been are to be initialized. Signal data that is to be fed to the data is to be initialized. So we need to run both of the files parallelly. So I'm running this. You can see few of the parameters has been generated in the workspace. Same for the signal data. When I'm clicking over this, you can see a signal has been generated for the system. So all these variables in the workspace will be used by the model that we have designed. So in order to run the model, you will only have this file with you. These are the temporary files, those are generated, so you can just delete them. So this is the main model file that you need to run. When you will double click on it, you can see such kind of model will be there. So this is the whole model that we have designed for the BESS system, in which this is the power PV based system, and this is basically the grid based system. So now see what we have done. Most of the systems those are working in the BESS are using the grid power or the static power to charge the battery BESS, and further many of the research has been conducted like charging and discharging module development. But the proposed methodology is identifying the problem in the current system, that the if the grid power is there, then the BESS is charging, else case there is no source of the power to maintain the consistency of the charging of the BESS, so that in the case of the emergency only it can be resolved. So inspired from that, in the proposed method, what we have done in addition with the grid, we are using the PV system, which is a renewable resource and continuously can be received on the environmental basis. So we are developing a hybrid model of solar system and grid system in order to charge the BESS, so that a continuous power can be fed to them, and in the case of the emergency only it can be done. In this in one of the system is designed by the solar, where the power has been taken, then second is with the grid and taking the decision that whether we need to switch to the solar one or we need to continue with the V grid. Then we are converting the AC to the DC, so that BESS can be charged on that behalf. So this module is for getting the power from the solar, along with this MPPT algorithm in which P and O method has been implemented. So you can just click on the MPPT algorithm and it will open a file in the MATLAB which is P and O method. You can read about the P and O method of MPPT extraction, which gives us the maximum power out of the solar power. So this is basically the grid system in which the system has is generating the values, and on that behalf AC to DC conversion is done, and finally a pulse is generated to decide the switching among the power from the solar or from the grid, and finally three-phase output is there, which is fed to the battery to get charged and further can be used for the certain circumstances. All the factors has been analyzed in the scope. So in let's have a run. In order to run this model, you just need to click on this run button and it will start executing. You can see it is compiling, and then you can click on this scope button in order to see the factors. Those are here. So in the meantime it is running. Let's talk about that, what exactly we have done. So you can see here the irradiance and the temperature value is given to the solar panel, which is generating the PV voltage, means solar power voltage, and solar current. So two of the values has been initiated. These two values are given to the MPPT, where it is generating the I reference, current reference, which will help to generate the maximum power from the system. This I reference is taken as a consideration to while converting to AC to DC. In the second scenario here, from the V grid we are getting the input from the grid, and continuously we are getting the weight values and the IDC current. These weight value is further converting the scenario by using this module of you can see this is a ABC to DQO transformation. So this is a transformer which is converting the three-phase ABC current to the ID, IQ and I node. These three inputs have been fed to the comparing the current that is considered from the solar power. So we are comparing the both, so it is deciding that whether which id pulse is to be generated from the pi controller. Similarly, in the case of like whether if we are not getting any input from the solar power, then whether we need to switch it or not. So this id and iq are deciding for generating the pulse for the module where the switching is decided. So this module and this module is fed here, where we are taking the decision and converting the signal to the reference signal, by which is also helping in converting to the AC to the DC, and finally PWM pulse is being generated, which is fed to this module, which is basically a universal bridge and behaving as switching among the power source of solar power and the grid. And finally, by using the L filter factoration, the data the signal is being transferred to the three-phase energy and further used for the grids and homes and other application where it is implemented. So now let's see that what results we got. So these are the parameters calculation and fed to the scope as a variable, so that we can see the analysis. So these are the factors that we do have in which we are achieving the results of I, ABC and I reference, mean PV current and the grid current. Second is the values of PV and AB, which is the grid's power and current and voltage. This is the actual signal and the received signal from the both of the scenarios. This is the voltage of the PV and the current of the PV, and this is finally the saturation that we have received due to the signal of the grid. So if I'm going to change this change the switching among data, so you can see if I'm rerunning it, it will reinitiate the whole process. And if as you can see, it is just started, and the results that we were analyzing here, the switching is different. I'm just switching it off by putting the value 1. I'm just switching it on, so you can see now the curve that we were receiving earlier will be different, and the signal will get switched to the PV. So a continuous signal is being received by both of the hybrid power sources, so that the BESS can get charged whenever the power is available, and only in the case of the emergency it start discharging. So these factors will give you the analysis of over system. So here you can see the curves are now increased with the PV. The signal from the grid has been overlapped. So this is how the both the systems has been switching among them. So this will here simulation is the manual one, but in the real time when it is implemented, there will be the auto switching, and the input will get switched between the both. So further modifications are still possible into it, and for that you can contact us directly. The industrial people or the research people can also contact us directly. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.